Okay, starting from where we left off with local extrema and zeros, let's keep going. Let's talk about the leading term test for polynomial in behavior. So remember, in behavior means that we are talking about as my x value approaches positive infinity for my function, what is happening? So as I move to the right on my function, where am I going? And the other way, if I take the limit as x approaches negative infinity of my function, I'm saying as I go to the left, where is my function going? Okay, and I put it in this order with the positive infinity first and the negative infinity second, because that's the order the book puts it in. So I figured that would be helpful. The leading term test for polynomial in behavior is basically that whatever our first term is, assuming it's in standard form, that determines the in behavior of my polynomial. If I zoom out enough to where I can see my whole graph, all of my extrema and zeros, then the in behavior I will see will be the same as if this was just y equals x cubed. Okay, so let's think about what does the graph of y equals x cubed look like? Well, it starts at 0, 0, it goes up to the right, goes down to the left. So if I'm answering this question, as I approach positive infinity, what is my function doing? Well, as I go to the right on x, I'm going towards positive infinity on y. So that would be positive infinity for that first question. The limit as x approaches infinity of my function goes to infinity. The other one, as I go to the left on my x, if I go to my left, I'm falling, okay, which means I'm going towards negative infinity. Now, if I look at this leading term, that I have negative 4x cubed, okay, a negative in front of my x cubed flips my graph across the x-axis, so that instead of the graph I just drew, this graph is going to have behavior where it goes down and to the right and up and to the left. Okay, this is just the in behavior. Other things are going on because I have this plus 2x and this plus 1, but just so I know what my end behavior is, I can look at this graph. So as I approach positive infinity, I'm going down towards negative infinity for y. As I go to the left as x goes to negative infinity, I'm going up on my graph to positive infinity. So what we can determine now is a rule for any odd power with a positive in front and with a negative in front. Okay, anytime you have an odd power as your leading term and you have a positive number in front of it, it will act just like the graph of x cubed. Okay, even if it's x to the 5th or x to the 7th or x to the 21st, the end behavior, which is all we are talking about here, will be the same as the x cubed graph, that I'm falling to the left, I'm rising to the right. If it's negative, it's the opposite and it looks like negative x cubed. Okay, that's the rule for odd powers. If I have a positive or if I have a negative, that's what my graph is doing. Now let's look at what happens if I have an even power. If I have 3x to the 4th for my leading term, that's a positive. X to the 4th is like a parabola in its simplest form, at least it is. So it goes up to the right and it goes up to the left. Okay, so as my x goes towards positive infinity, on my y I'm going up towards infinity. And then as my graph approaches negative infinity, I'm going up towards positive infinity. So here my end behavior is the same. Either direction I go, I'm going up, If I start in the middle, I'm going up either direction, so that's positive infinity and positive infinity. If I look at now a negative for x to the fourth, then on this graph, this is a parabola. It looks like a parabola that opens down. It's not actually the same because it's a quartic graph, not a quadratic, but it's opening down because of the negative. Well, that means that my end behavior is going to be negative infinity and negative infinity, because as I go towards the positive infinity on the x-axis, I'm going down. As I'm going towards the negative infinity on the x-axis, I'm going down. Now, just to clarify, all of these things I've written, these are the answers to these two questions. I'm not saying that this is a point or an interval or anything. I'm answering the first question in the first spot, and I'm answering the second question I have in the second spot, just to clarify. Okay, now let's write our rule for end behavior on even powers. If it's an even power and it's positive, it's going to look just like the quartic graph, but even more simply, it really has the end behavior as x squared. Okay, and the negative has the same end behavior as negative x squared. So as long as you can come up with what the end behavior is for x cubed and negative x cubed, x squared and negative x squared, you can figure out the end behavior for any polynomial function using the leading term test without having to graph it, which is really neat because that way we don't have to come up with the perfect window to figure out what our graph actually looks like, because that's really annoying to have to do. Okay, so that's the leading term test for polynomial end behavior. The next thing we want to look at is finding the zeros of a polynomial function. We'll be doing this a lot. So on this particular problem, we're going to look at this algebraically first, and then we're going to look at it graphically. Okay, or we'll just talk about how to do it graphically. Maybe, we'll see. So algebraically, if I want to find the zeros of f of x equals x cubed plus x squared minus 6x, what I'm saying is if this equals 0, what are my x values? Okay, so let's refresh ourselves on some algebra. Okay, the first thing I want to do, because I'm going to try to factor this, is I'm going to say, well, all of them have an x, so let me factor out an x. That leaves me with x squared plus x minus 6. Okay, then I can factor that set of parentheses into two more sets of parentheses. This is where, if we remember, we're looking for what multiplies together to give me negative 6 that will add or subtract together to give me a positive 1. So things that multiply together to get negative 6 are like 2 and 3 and 1 and 6. And so I would want to take the 2 and the 3 and make the 3 positive, because I want to say 3 minus 2 gives me a positive 1. So x plus 3 and x minus 2. Now the reason I factored this is because there's this property where if I have things multiplied together like this and they equal 0, then I can say each part equals 0 and solve, and that gives me my zeros. Okay, well, I don't have to solve x equals 0, it's already solved, but this would be x equals negative 3 because we just move it to the other side, and x equals positive 2. So I have 3 zeros at x equals 0, x equals negative 3, and x equals 2. And if we think back to what we said about polynomial functions, this is a degree of 3, so at most it can have 3 answers. If I'd somehow ended up with 4, I would know, hey, I screwed up somewhere. Okay, graphically, what happens is that we go into y equals and we plug in this function. And so on my calculator, it's going to look something like this. Okay, we put that into y equals. We're going to graph this, which we can start off by zooming 6 if our window is messed up to get a standard window. And then what we want to do is see, can I see everything that's going on in my graph? So let's go ahead and look at this on a graphing calculator. So bear with me for a second. I'm going to come over here to my graphing calculator. I'm going to turn off this because we're going to use this one later and I don't really want to have to plug it back in. So I'm graphing in y2 x to the third plus x squared minus 6x. And so I'm going to go ahead and zoom 6 to make sure I have a good window. And this actually is really a perfect window for me to sit here and graph, because I can say second trace, which is my calculate menu. I want to calculate the zeros. And then what I'm going to do is go through each zero. So I'm going to start on the left. I'm going to go through each zero. Okay, I'm on the left side of my zero. That's on the farthest left. Press enter. I'm going to move it to where it's on the right side of my zero and press enter. And then I'm going to ask it to guess. And it gives me -3, which was one of our zeros. If I do that on these other ones, it works the same way. That now I go to the left of my next zero, and then to the right of my next zero. I press enter and ask it to guess 0, 0. If we do the same thing for the last one, we'll get 2. Okay, so that's how you do it algebraically and graphically. Some of them we will have to do graphically. We just don't really have a choice. There's not a good way of factoring, so we'll have to do some of them graphically. But it is also good to know how to do it the algebraic way in case I ask you to do it the algebraic way, right? All right, this will be the end of part 2.